Hey everyone, welcome to section 11.2 on transformations and translations of parabolas. This is Nick Jacobs, your instructor here for intermediate algebra at Yavapai College. In 11.1, we kind of introduced quadratics, and now we're going to kind of go a little bit more in depth on them. And some of this we've actually introduced in a previous section, but we're going to get into a little bit and a lot more detail today. So this may be another longer lecture, but please watch everything and take good notes as we're going through all of this. So some objectives, we're going to graph basic transformations, okay, of any parabola basically, or anything that has that x squared value in it. Okay. So we're gonna be doing vertical and horizontal translations of them. We're gonna also learn what vertex form is of a quadratic, and then we're gonna be doing a little bit of modeling with some quadratic functions in here. So let's go ahead. So what is a transformation? It's basically what we're doing here in this section is we're taking the graph of y equals ax squared. And again, where a could actually be greater than 0 or it could be less than 0. But we're taking the graph of a parabola, right? And we are doing certain things to it to see how it affects it. Okay, so sometimes we might have a number in front of x squared. Sometimes we might have maybe like x minus 3 or x plus 3. Sometimes we might have a x minus 3 squared plus 1, whatever. We're going to learn what all that means in this section. So basically here, if you have a number in front of x squared, we call it a. Okay, if a is greater than 0, we learned last section that the graph is never going to lie below the x-axis, basically. Okay, if there's nothing else along with it, so if there's not a plus or a minus out here. Okay, and another thing we have to also look at is the number here. Is it a is it greater than 1, or is it between 0 and 1? Okay, is it a fraction? If it is basically if it's greater than 1, it's going to be closer to the y-axis. So this is this green graph right here. This is 2x squared. So it actually gets closer to the x-axis. Our graph of y equals x squared is right here. That's kind of our base function here that we call it. But this is 1/2 x squared, so that's a little bit wider. All right, so it actually widens out from our base function of y equals x squared. Now, if I had something like y equals 1/8 x squared, okay, that's going to be even wider. Okay, that's going to be even farther away from the y-axis. But if I have, so I'll just say this is wider, okay? But if I have y equals 8x squared, this is going to be narrower. So it's going to be really close to the y-axis. So it's going to kind of, get narrower and kind of longer here. Now, if we have where it's y equals a negative x squared, we learned last section that that's going to flip it. So it's going to be facing downward instead of here where it's facing upward. And same idea here. If it's greater than not greater than -1, but if it's less than -1, it's going to be closer to the y-axis. And if it's between 0 and -1, not including 0, it's going to be wider. Okay, so to kind of summarize there, right? The graph of y equals ax squared is a parabola with the following characteristics. Okay, and again, nothing is next to this ax squared, and we will talk about that here in a little bit. But the vertex here of this graph is going to be 0, 0. And then the axis of symmetry, like we talked about last time, is x equals 0 or the y-axis, right? This is the y-axis. Okay, it opens upward if a is greater than 0 and downward if a is less than 0. So we talked about some of that. And again, it's wider than the graph if a is between 0 and 1, not including 0 and 1, right? So it kind of stretches out, and it's narrower, or it's closer to the y-axis if a is greater than 1, or if the absolute value, sorry, I should say if a is greater than 1. Same thing over here, the absolute value of a. So if we're talking about these graphs here, so let's compare the graph of g of x equals negative 4x to the graph of f of x equals x squared. And then we're going to graph those. So what could we say here? Well, since we have this x squared value, okay, this is x squared, this is x squared, we know that they are both a parabola, right? So they're both parabolas. But the graph of g, or this g function here, opens downward. How do we know that? Because a is less than 0 right here. But then, so it opens downward, and then it's also narrower than the graph of f, right? Because this is less than a negative 1, okay? Or the absolute value of a is greater than 1 is another way that you could say it, okay? So if we're trying to kind of graph these, okay, f of x equals x squared, this is just the graph of kind of our base function, x squared, okay? And then this is the negative 4x squared, okay? And we could figure those out by making a table, right, of x and y values, and then plotting those points and graphing them. Okay, you could also use Desmos as well in this. Now, the next thing that we do here is we're going to talk about vertical and horizontal translations. Okay, so we already know that the graph of y equals x squared is a parabola opening upward with a vertex of 0, 0, right? That's this blue graph right here. Okay. We know all three of these graphs are basically going to have the same shape because they're all x squareds, right? That's the highest degree or the highest exponent there. Okay, actually, they only have an exponent of 2, but just so you know, they could have, x squared plus x plus 1 or something. Okay, they'd still be in the shape of a parabola, right? But now we have, what we're focusing on is basically a is going to be 1 for all these. So we have a 1 out in front. But now what we're doing is we're either adding or subtracting after the x squared. And we want to know how that affects the graph. So if we have something where it's x squared plus 1 or plus 5 or whatever, that's basically going to shift the entire graph upward, however many units it is. So in this case, 1 unit. So this red graph here, x squared plus 1, has all these plotted points that they did have been shifted up 1, okay? And then if it's x squared minus something, in this case minus 2, all the points are going to be shifted downward 2 units, okay? So all the points on the green graph here compared to the blue graph have been shifted down 2 units. Okay, and we call those shifts translations because they don't change the shape of the graph, but they only change the position of the graph. Okay, so if I have, another type of, another type of translation would be a vertical and horizontal translation, right? Or basically shifts here. So we're gonna, okay, let me take a step back. We just covered vertical translations, okay, either up or down. Horizontal is gonna be left or right, okay? So vertical, right, up or down. Oops, I don't know why that showed up there. And then vertical is gonna be left and right. Let me rewrite that here. Okay, so this is up or down, and horizontal is gonna be either left or right. Okay, and we're going to talk about horizontal shifts here. So if I have something where it's x minus 1 squared and it's in a parentheses, okay, basically what that's going to do is it's going to shift everything to the right 1 unit. Okay, so the blue graph here is our base function y equals x squared. And actually y sub 1, I haven't been saying the subs or the subscripts here, but kind of get the idea. The red graph was all these points were shifted to the right 1 unit. And this is kind of interesting because sometimes people think, oh, well, why is it to the right when it's a minus? Okay, well, wouldn't it be to the left? You know, thinking about on a number line, right? Negatives are to the left, but actually it's kind of the opposite in this case. Okay. It's actually shifted the opposite way of what you think it is. So it's actually to the right, where if I have, you know, x plus, let's say 1 squared, this is going to shift to the left. This is going to shift to the left 1 unit, whereas x minus 1 squared is shifted to the right 1 unit. Okay. And again, you can make an XY chart and kind of figure that out, right? Plug the values or substitute them in and then find out what they are. Okay. Okay, so this is where we have like an x plus something. Okay. So again, I just kind of showed you that here, but if I have a parentheses around an x plus 2 squared, okay, that's actually going to shift it to the left 2 units. Okay, and what we're going to do next is we're going to do something like this. We're going to say, well, what happens if you have like parenthesis x plus 2 squared, and then let's say plus 2 on the outside of that. Okay, well, basically what would happen here is, I'll kind of give it away, is this is going to shift left 2, and it's also going to shift up 2. Okay. All right. I'm going to actually pause the recording, then I'll come back here and onto the next slide. All right, so I had to pause it there. I had a phone call, so I'll go on to the next slide here. We'll keep talking about vertical and horizontal translations here. So kind of to summarize here with this. So with these graphs, they kind of use H and K to represent some of the shifts here. But if you have, again, that x squared and it's plus k, it's going to be an upward shift. If you have x squared minus k, it's downward. But then it kind of flips, right? So if I have x minus h squared, that's actually going to shift the graph to the right by that many units. And then if it's x plus h squared, it's going to shift to the left. So kind of the opposite of maybe what you would think for those. So it's really good and really important to know these, to have them kind of memorized, so you can know what is happening in the graphs here. So if I needed to sketch the graph of this equation, so let's say you know, I have this y equals x squared minus 3. Okay. Basically what they want here is to sketch a graph and identify the vertex. Well, what I kind of want you to do is, before you sketch it, I want you to say, okay, well, what is actually happening here? So if it's x squared minus 3, this means what? This means that the minus 3 sits outside of the x squared. There's no parentheses. Okay. It means that it's going to shift it down. It's going to shift it down 3. And what does that mean? It means it's going to shift the base function. Okay, we can call it y equals x squared. Okay, how does that shift? It shifts down 3. Okay, down 3 units. Okay, so if I know the graph of y equals x squared, okay, and if you don't know, figure it out, right? Let's put some points in there. So if I have, let's say, -2, -1, 0, 1, and 2, and I square all of those, -2 squared is 4, -1 squared is 1, 0 squared is 0, and then 1 and 4, I could plot all those points, right? And that's your base function here. Oops. Pretend that they are actually connected here. But if I then graph this guy right here, okay, all the x values are going to stay the same, okay, but all the y values are going to shift down. So basically what you could do is you could take all these values and you could subtract 3 from them. So I would have 1, -2, -3, -2, and 1. Okay, and then graph all of those points. So basically all of these are going to be shifted down by 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, and that's going to be the graph of y equals x squared minus 3. Okay, as that's literally what it means. We're taking all of these guys and we're shifting them down 3. Okay, now if I have this, right? Oops, I actually forgot to do something. What is the vertex here, right? I have to identify, whoops, the vertex. And I just lost it. There we go. What is the vertex? Well, the vertex for our base function, oops, I just did it again. Trying to switch colors. There we go. The vertex for our base function was 0, 0. The vertex now is at 0, -3. Okay, so the vertex is 0, -3. All right, this next one has our x plus 4 in a parenthesis, right? And nothing outside here. So what does this mean? It's going to be a horizontal translation or a horizontal shift. So this is going to shift. So the graph of y equals x squared is shifted 4 units, which way? Well, it's x plus 4, so it's 4 units left. Okay, so again, you can kind of graph your base function here. Okay, and all we're doing is really, we're just sketching this. Okay, so if you kind of know that this blue is, y equals x squared, okay, your base function. And it's a parabola, it's in that U shape again. And then we just move all these dots 4 places to the left. So 1, 2, 3, 4. 1, 2, 3, 4. Here, here, and 1, 2, 3. Oh, it's going to be on the same point. Okay. So that's what this one is going to look like. Okay, and what is your new vertex? Well, the vertex is at -4, 0. Again, the y value stayed the same, but it shifted to the left 4, so the x value is affected there. Okay, and we can say vertex is -4, 0, or you can just say vertex -4, 0. Some people say v -4, 0. Doesn't matter really, they'll have maybe different notation on your homework. I'm not quite sure what that is. I haven't checked yet, but one of those forms. Okay, now here is one where we're doing 2 translations in the same one. Okay, so we have y equals x minus 1 squared and then -2. Okay, so what does this mean? Well, what's in parentheses, okay, this is going to mean it's going to shift what? It's going to shift, whoops. It's going to shift right 1 and then down 2. Okay, because of the -2 and this -1. Okay, so let's go take that here. So we have y equals x squared. That's going to be this graph. All right, you should kind of know this by now, at least plotting some of the points on there. Kind of looks something like that. And then we're going to be taking this y equals x minus 1 squared minus 2, and we're going to shift to the right 1 and down 2. So here is the new vertex. Okay, so the vertex is at what? Well, to right 1, so 1 comma -2, right? It was at 0, 0, 0. And then we just shift all those points. So right 1 down 2, right 1 down 2, here, and then here. And that's the graph of our new translated function y equals x minus 1 squared minus 2. Okay, now the next thing that I want to cover is what we call the vertex form of a parabola. Okay, and what they use here, and this is, I don't like how they used h and k before. It's kind of why I hesitated. They used h and k for the shifts there, but it's very standard to use h and k for a vertex. Okay, so the vertex, how they usually notate it is it's h comma k, or excuse me, where h is the x value of the vertex. Let me get some water, and k is the y value. And then a is kind of that leading constant, right? That we've been talking about. But again, a, it cannot equal 0, right? That would just make this whole thing 0. And the same rules apply. If a is greater than 0, the parabola is going to open upward. If a is less than 0, the parabola is going to open downward. So this is your vertex form with a vertex of hk. So I'm going to refer back to that, that vertex form, but and we'll talk about it here in some of these next slides. So let's compare the graph of f of x to the graph of, or sorry, the graph of y equals f of x, which is this guy, to the graph of y equals x squared. Then we're going to sketch a graph of y equals f of x and y equals x squared in the same xy plane, or on the same graph. So, oops, I didn't want to click ahead there. But what does this mean? Okay, if you're looking at this, we're going to try and figure out what these shifts are. Okay, well, I usually start inside of the parentheses. Okay, and I know it's x minus 2 squared. Okay, and the minus 2 means what? It means that I'm going to shift it to the right 2 units. Okay, and the plus 3 on the outside, if you look back at your rules, right, means I'm going to shift it up 3 units. And what does the 1/4 mean? Well, that just means that what, it's going to be wider. Okay, so it's going to be wider than y equals x squared. Okay, so you know, if this is our graph, okay, x squared is going to be narrower, so it's going to be like this. Okay, kind of making a smiley face. I just realized that. Anyway, here is our graph. Okay, so the blue graph is y equals x squared, and this has been shifted to the right 2, up 3, and we can see that doing that is going to make it a little bit wider. Okay, it's wider because of this 1/4 again. So not really shifting it is going to make it wider, but the 1/4 makes it wider. Okay, so all of these have been shifted 1, 2 to the right, and up 3. Okay, so if this point right here, 2 to the right, 1, 2, and up 3, 1, 2, 3, but it's wider. Okay, that's why it's a little bit over here. Okay, but your vertex, right, your vertex keeps that shift. Okay, all the other points are going to be a little bit wider. So it goes to the right 2 and then up 3. Okay, and that's our new vertex right here at 2, 3. All right. So now we're kind of going to be doing the opposite. We're kind of given our vertex, we're given the a value, and we're going to express this equation in this form. Okay, this is our standard form of a parabola, right? So we're going to express it in standard form. Standard form. But first, what are we given? We're given an A value and we're given a vertex. Okay. Well, with those, just given those two things, I can make this into standard form. Okay. I just need to know a couple of things. So if A equals 3 and your vertex is 2, 1, remember the notation that they used for the vertex was H comma K. So what can I say here? Well, I know that A equals 3. I know that H equals 2, right? And then K equals 1. And I also know the vertex form now of a parabola. It's y equals a times x minus h squared plus k, right? That's our vertex form. So now what I do here is I substitute. So I have a equals 3. I have just x here, x minus 2, right? And then plus 1. So I just substitute those. Don't worry about the minus and the plus, just keep those the same always. Okay. And now I need it in standard form. So this is vertex form. This is vertex form. Make it into standard form by, well, we're just going to expand this, or we're going to multiply all this out. So I look at the x minus 2 squared. Okay, what does that mean? That means I have x minus 2 times x minus 2, right? And I'm going to FOIL that out. So I have x squared minus 2x plus 4. You should be very comfortable with that by now, which is x squared minus 4x, combined like terms, plus 4. And so maybe some of you could have told me that without even doing all this work. Okay. So first thing we do is we're going to square this, right? Kind of do our order of operations. Okay, parentheses and exponents first. Now we're going to multiply. So let's multiply this 3 through. So we have 3 times x squared. 3 and then negative 4x is negative 12x. 3 times 4 is 12. And we have the plus 1 over here at the end. And then just combine like terms here. So we have the 12 plus the 1 gives us 13. So this here is your standard. Whoops, well, I was writing form and standard in the same word. Okay, so standard form here is y equals 3x squared minus 12x plus 13. Okay, that's what they wanted here. So we kind of had taken this vertex form and kind of translated the graph, okay, and explained what we were doing. Now we're given an a value. Okay, and we're given an h and a k value from a vertex, and we're writing it in standard form. I could take this guy and I could write it in standard form. I would just multiply all this out. Okay, but I'm not going to do that, but we could. Okay, we could do that. All right, next thing we're going to do is a little bit of an introduction to completing the square. We're going to cover more on completing the square in section 11.3, but a couple of the homework problems might require that you do this. So what is completing the square? Why do we use it? So basically, we use the method of completing the square. So it's a method when we're given the vertex form, or sorry, you're asked for the vertex form, but you're given the standard form. So you might be given this guy, okay, y equals 3x squared minus 12x plus 13. And they might ask you to put this back into vertex form. So you're going to kind of go backwards, okay? That's the whole point. So given standard form, write a parabola or the equation of a quadratic function in vertex form, okay? And again, I'm going to introduce this more, or I'm introducing it now, but I'm going to cover it more in section 11.3. But basically, how we do that to go from standard form to vertex form is we need to manipulate the standard form of a parabola, okay, function by adding and subtracting b over 2 squared. Okay, and I'm going to do some examples. So the key here is knowing this. okay? B over 2 squared. And remember, the standard form is y equals ax squared plus bx plus c, okay? We're trying to achieve this vertex form, okay? So we're trying to take this guy and we're trying to make it into this. Okay, and we just use different variables here to represent different things, but kind of get the idea, okay? Trying to go from here to here, but be careful. If a is not equal to 1, you have to make it 1 first. So you have to basically factor it out if that's the case. And I'll show you an example of that as well. So let's do an example. We're going to write this equation in vertex form and identify the vertex. So right now it is in standard form, okay? Let's work to write it in vertex form. So a couple of things we need to know, okay? Remember that the standard form that we talked about in section 11.1 is y equals ax squared plus bx plus c, okay? And what we're going to be using here to do completing the square is b over 2 squared, okay? So you can see here that this guy is not factorable, okay? X squared minus 8x plus 13 is not factorable. So what do we need? We need to make it so it is factorable. Okay, and how we do that is we complete the square. We use this guy, okay? And where does this go? Well, oh, and by the way, notice that a is equal to 1 here, okay? A is equal to 1. If a was not equal to 1, we would have to make it equal to 1, and we'll do that in the next example. But this is a 1 right here, okay? Now, what I do is I take these first 2 terms, x squared minus 8x, I write them out. And then I need a place, kind of a placeholder here. And let me do it in blue. Okay, I need something right here. So I need something here. And then I have the plus 13. But when I do that, I'm going to add that something and I'm going to subtract that something. Okay, and that something is this guy. Okay, the b over 2 squared. Okay, well, let's do that. Okay, let's find what b over 2 squared is. So what is b over 2 squared? Well, b in this case is what? B in this case equals 8, or sorry, not 8, but negative 8. So then b over 2 squared is equal to negative 8 over 2 squared, which is negative 4 squared, which is 16. So what am I doing here? I'm adding and subtracting 16 from this, okay? Adding and subtracting 16 from this. Actually, why don't I redo that here? Oops. Why don't I do that? Why don't I do all this in red? Okay, so you kind of get the idea here. Okay, so oops, I did not want to do that. Here we go. Let me change it to red. So I'm taking this guy and I'm figuring out what is b over 2 squared. Well, it's the negative 8 over 2 squared, which is negative 4 squared, which is 16. And I'm adding 16 and I'm subtracting 16 as well. Okay. Now, what was the whole point of that? Okay. Well, I didn't change this equation. That's the first thing that I wanted to point out. If I'm adding and subtracting the same number, 16 minus 16 is 0. I'm not changing it. Okay. I'm just rewriting it so I can achieve vertex form, right? Now, the whole point was this guy now is actually factorable. Okay, so this is factorable. Okay, and this is our perfect square trinomial, what we call it, right? Where x squared is a perfect square, 16 is a perfect square. When I have that, I can write it as x minus what? Well, x minus 4 squared, right? Because x minus 4 squared would be this trinomial, okay, this perfect square trinomial. Remember, we took the to kind of a shortcut. We took the square root of x squared, which is x, and we took the square root of 16, which is 4. And this sign has to be a minus in order to achieve this guy. Okay, but then we have 13 minus 16, which is a minus 3. And look at that. We just have achieved our vertex form of this parabola. Okay, y equals x minus 4 squared minus 3. And what is the vertex in this case, right? They wanted the vertex. Well, remember our standard, sorry, not our standard form, our vertex form was y equals a minus x, or sorry, a times parenthesis x minus h squared plus k, right? Where your vertex is h comma k. And some people would say the vertex here is positive 4, or sorry, not positive 4, negative 4. But we actually would kind of think of this as setting it equal to 0. And the 4 is actually going to be positive there, okay? Because it's just the h value, not this sign, basically, okay? So it's 4 comma what? Well, here we actually do carry the sign. So it's 4 negative 3. So kind of confusing there, but that's going to be your vertex. So 2 different answers here. Just note that inside the parentheses, kind of the opposite sign, and then outside we carry the sign. All right, and that was, why is that again? That's kind of based on our translations, right? X minus 4, we would be moving it right 4, so we get a positive 4, and then minus 3, we're going down 3, so negative 3. All right, now let's do a completing the square where a is not equal to 1. So in this case, a equals what? A is equal to 2, right? Where we have our standard form, ax squared plus bx plus c. A is equal to 2 in this case. So a is not equal to 1. This is very, very important. So when our leading coefficient or our leading constant here is not 1, it's 2 in this case, what we're going to do is we're going to start by factoring 2 from the first 2 terms on the right side. So I take my standard form of this quadratic. How do I know it's a quadratic? Because there's an x squared term. And I'm going to take this and I'm going to basically separate this out. I have 2x squared plus 8x. Then I have my something and then plus something. But the thing is here, I need to factor first. So I'm going to factor out a 2 from these 2 guys. Okay, not your greatest common factor, but just your common factor from your coefficients, 2 and 8. So I factor out a 2 there. So now I have x squared plus 4x, right? Plus something. And then actually I didn't want to do that on the outside there. When it's like this, actually what you're going to do is you're going to plus and minus it on the same kind of thing here. So plus and minus it both on the inside of the parentheses, and then you have your 7 on the outside. So that's kind of a special step here. Again, when a is not equal to 1. Now, what is this underlined thing? What is that underlined something? Well, that is b over 2 squared, right, is our underlined something. Well, what's b in this case? B is actually this. Okay, it's not the 8, it's after you factor it. So it's the 4. So it's 4. Okay, so b is equal to 4. It's 4 over 2 squared. 4 over 2 is 2. 2 squared. 2 squared is equal to 4. So this guy is going to be, let me do it in red. This is 4. I'm going to add 4, and then I'm also going to subtract 4. Okay. basically on the same thing. So, but there's a little bit of a trick to this, because when I'm writing this out, okay, I have that this guy is going to be factorable, right? The x squared plus 4x plus 4. That was the whole point. That was the whole purpose of this. Okay, but I still have the plus 7 on the outside. And then what would happen when I would distribute this 2? Well, I have the 2 times the 4 still, but then 2 and negative 4 is going to be what? Well, I distribute it and I put it on the outside there as a negative 8, actually. Okay, because 2 times negative 4 is 8. So just notice there, this really important step. Okay, when we do this, completing the square with a is not equal to 1, okay, we factor out from our first 2, okay, put that on the outside, and then I have my b over 2 squared term on the inside of the parentheses. I'm adding it and I subtract it. Okay, this portion is now factorable. Okay, these first 3 terms are factorable. And then the last term is not part of that, right? In this case, the minus 4. But I'm going to put that, if I were to distribute it with the 2, I'm going to put that on the outside as a minus 8. So really, really important step here. Now I'm going to keep going just a little bit. And I'm going to just do the plus 7 minus 8 is minus 1. Now let's factor. Okay, let's factor even more. What is x squared plus 4x plus 4? Well, that's one of our perfect square trinomials. And I know that because the first term and the last term are both perfect squares. Okay. And when I square root them, x squared, square root of x squared is x. Square root of 4 is 2. This guy would FOIL into this. So x plus 2 squared would FOIL into x squared plus 4x plus 4. And then I still have this minus 1 on the outside. So this guy is now in our vertex form. Okay, this is now in our vertex form right here. Okay, and what is the vertex? Okay, well, the vertex is, well, x plus 2 would mean I'm going to the left 2. So it's minus 2 and down 1, negative 1. So negative 2, negative 1 for the vertex. Okay. And I just have an example of a homework question here, and then maybe I'll go back and try to complete the square from what we had earlier on. I know this is getting longer, but I want you guys to have some examples here. So first, let's do this homework question. They ask us to write the vertex form of the parabola shown in the graph. Okay, so write the vertex form, right? Vertex form is, looks like this. We should know that by now from this lecture. And assume that a is equal to either positive 1 or negative 1. Okay, well, what do we need here? We need our vertex. Okay, what is the vertex, right? Our vertex is h comma k. What is the vertex? Okay, the vertex is right here. It is 1, 2, negative 3, comma 1, 2, it's 2. Okay, so again, the vertex is either the highest or the lowest point on our parabola, right? So in this case, it is negative 3, 2. So when I'm filling this guy in here, I have x minus negative 3, and then plus 2. What's our a value? Well, from last section, it's opening downward, right? So it's going to be negative 1. And then I see here that I have a minus, that's going to become a plus. Oops, I forgot to square this. And so it's y equals negative 1 because it's opening downward. And x plus 3 squared plus 2, you can kind of double check this, right? This would mean that it would be translated 3 units to the left, and it is from our original vertex, okay, at 0, 0 from y equals x squared. 3 units to the left, 2 units up, and it's down, so the sign is negative. Okay. All right, that is all of the examples that I have. Let me see if I go back. Where was that one that we were working on? Right here. Okay. if I would try to go backwards. That's what I'm talking about here. Let me actually do that in red. Okay, let's complete the square to go backwards. Complete the square. Maybe I have enough space in it here. So I would be going backwards. I would be working with this standard form. Okay. And I notice that a is not equal to 1. It's equal to 3. So what I need to do here is I need to basically factor out a 3 from these first two terms. So I factor out a 3 and I get x squared minus, well, factoring out a 3 from 12 would be 4x there. And then I would need to add something on the inside and subtract something. And I have that plus 13 on the outside. Okay. Well, what do I add and subtract? Okay. Well, I add and subtract that b over 2 squared. And again, the b value comes from this guy. So in this case, it's -4. So -4 over 2 squared is equal to 4. So I add 4 and I subtract 4. I like 4 in this section apparently. And then it would be equal to this. But remember, this last term here, the -4, I would distribute. The 3 times -4 is -12. That goes next to the 13 on the outside in this case. Okay, so in this case, it's plus 13, but the -12 minus 12 goes on the outside. And then I keep going with it. Well, this is now our perfect square trinomial. This is x minus 2 quantity squared. 13 minus 12 is +1. So that would be this form here, our vertex form. We just took this and we went backwards, okay, from our standard form. And that's just another example for you guys of completing the square. I know I went a little bit fast there, but try to look through some of the steps. And we will work more on completing the square during the next section. So again, next section is 11.3. We'll see you all then for that. And thanks for watching.